Oh, that's good. So we will have a second section of the carbohydrates. We're going to talk about oligosaccharides. Basically, is a disaccharide. We'll give you some example. So let's look at the oligosaccharides. So oligosaccharides basically is composed by 2 to 10 carbon. And then they need to forming glycosidic bonds. Because they need to form glycosidic bonds, so they need to either donate from some places or either from hydrolysis. So therefore, there is two different types of the oligosaccharides. Number one is we call it a primary. Of course, number two is called secondary. The primary basically is coming from, you have a donor for glycoside. And this is needs rely on an enzyme called transferase. A good example will be sucrose. And then we'll get to detail of sucrose real quick. The secondary glycosidic bonds coming from is a hydrolysis of polysaccharides. Now, we'll care more about here is disaccharide. Disaccharides, usually we call it a double sugar sometimes. And we also mentioned a concept called reducing sugar, which means you had a free hydroxy bonds. We could be using hydroxy components, could be using. Then if it's a reducing sugar, it's easily to be involved in a Maillard reaction. If it's not a reducing sugar, you need to break down, become reducing sugar first. Then can be involved in the Maillard reaction. And this is, we already talked about that. And also the last thing we want to talk about is the oligosaccharides made most of the time is from plants. Not from animals, it's from plants. Okay, so that's the overall oligosaccharides. We gave the opening remarks. Now next we want to mention some detail about 3 disaccharides. Talk about these a little bit in detail. What are they, their characteristics? So the first thing what we want to talk is sucrose. Okay. What is sucrose? Sucrose is the structure. It looks like there is a glucose. Okay, then go here, here. So this is CHO2. This is on the top. Now, say it very easy, sucrose is combined by glucose and fructose. And they are combined here. This is called acido bonds because there is no free available hydroxy. So we can say there is no hemi no semi-acyl. Okay, so this is not a reducing sugar. So this is the basic structure. If you want to say a more detail, then they give you, from the chemistry standpoint, they go more detail, which is called beta D fructose fructonyl and alpha D glucopyranols. That's, we don't have to go bottom of that. Okay, you just only need to know this is come from glucose and fructose. This is a major sugar, contribute to the sweetener. And also manufacturing lots of table sugar in the United States. There is a survey which is showing averagely we taking 55 to 160 grams annually for one person in the United States. Total is 160. If we take in consideration of some fermentation, could we go down to 55? Now, we know the sweetener, the table sugar, how they come from. They come from two resources. Number one is sugar cane. Number two is sugar beets. And we will talk about sugar refining real quick. Okay? Now, number four, we want to mention, for sucrose, it is very sensitive to acid. So, for example, citric acids. Once you have a citric acid there, or acid, it will be breakdown between glucose and fructose. Also, it is not really thermal stable. Once you have a high heat, okay, let's say 180 degrees Celsius to 210 degrees Celsius, this will also break down to glucose, fructose, also have caramel. And this relates to the caramelization. We will mention this more detail in a few seconds, real quick. And this is an excellent ingredients for syrup. Okay? And when you see here, this is also a good carbonyl to carbonyl to carbonyl linkage. Okay, so we briefly introduce you here, but then we go back to here more detail. This figure, which is showing you why sucrose is a very good resource of the table sugar. Because its solubility in the liquid is not changed too much with the increasing of the temperature. And you know that glucose, lactose, they'll dissolve much more quick in the high temperature. Sucrose doesn't change too much. However, we did mention, when you're using higher temperature, the sugar like fructose, glucose, and lactose, typically fructose, the sweetness will be decreased because it becomes an open ring. From a wash configuration become like a fissure configuration. So once the ring has been opened, then they will lose the fructose, or they will lose the sweetness. Okay, so you need to know, sucrose is very steady for the solubility, and also very stable with the sweetness. But the others is not really. They increase their solubility in the solubility with increasing of the temperature. The sweetness is actually little bit or severely decreased. It depends what type of the sugar. Okay, so this is the first one. the sucrose. Okay, second one, we want to talk about the lactose. Now, number one, what is the lactose structure? Lactose structure, you can easily understand it, are very, very similar. Seems like it's two glucose they combine. Okay, so and those here. Sometimes they go that way. This one goes up. Okay, so this one goes up. Opposite direction. This one goes up. This one goes down. This goes up, this one goes down. So here we have this one goes down, this one goes down. So I here made a mistake. OH. Okay, this I want to be pointed out. Okay, they combined by D glucose and D galactose. D-glucose and galactose. The lactose. And this is we call milk sugar. Nickname. Why? There are higher amount in the milk. About cow milk, 4 to 5%. Human breast milk, around 7 to 8%. We can use the lactose. You must have lactase or beta glycosidase. You must have that. Okay? So basically, lactose, you have to become glucose and galactose. You need to have the enzyme which is called lactase or beta glycosidase. Okay, now we want to mention something. Since we talk about this, we want to mention two things. If you learned in the general microbiology or learned in your genetics class, for bacteria, if they grow with glucose and with lactose together in the same environment, they will using glucose first. When the glucose used all, then they use lactose. Okay, this is what we talk about in the microbiology class because it relates to lacto-operant. So we don't go bottom of this here. Now here we want to talk about is very happened in the human being is lactose intolerance. Now what is lactose intolerance? Some people genetically do not have lactase or beta glycosidase. So what happened? The lactose in the lower part of small intestinal will be partially hydrolyzed. Not completely. Especially you drink some milk. Then what's going to happen? This is a lumen of small intestinal. If you have lactose there, what's going to happen? Okay, let's say lactose is there. Then will cause osmotic imbalance. What's the results? All the water going to pour in. Because this is more higher osmotic pressure compared to here. So all the water goes here. What's the results? Discomfort and diarrhea. Okay? That's why we'll cause lactose intolerance. Now, how we solve this problem? The question is, I shouldn't do remove this one, okay? How to solve the problem? What's the treatment? There is basically three treatments. Number one, you can drink yogurt. Because yogurt going through fermentation, remove lactose. That's why that's one of the recommendations. Second, you're using milk powder instead of using whole milk or milk liquid, because most of the milk powder has lactose in, lactase in. Number three, you can drink milk, but you need to take beta glycol acidic, which means it's an enzyme product. Therefore, in the real life, most of people do this way, or some people using this. Very few people do that, although theoretically it works. Okay, so that's how they do for the lactose intolerance, how to solve the problem. Now, we want to mention one thing. I shouldn't have drawn this off. This goes off. This goes this. This goes on top. Lactose is a reducing sugar because of this guy. Okay, this is hemiacetal. So they can be, it's a free available hydroxy base, so it can be used. So therefore, lactose could be going through Maillard reaction. Okay, now the last question. How we differentiate lactose to sucrose? A very easy way is using citric acids. Lactose will not hydrolyze. Sucrose will. Sucrose will break down between glucose and the fructose, and the lactose is kind of stable in the citric acids. Okay? So this is something we want to mention for the lactose. Okay. Now we want to mention another thing. maltose or maltose. Okay, why I say I should remove this figure? The structure. Maltose and the lactose looks very similar. I'm not going to go bottom of that complicated name. So-called beta-glucopyranoise or beta-glucopyranosyl. Those are very similar. What's the difference? If you want to remember, easily understanding, this guy goes here and just switch. Okay? Just put hydroxy go down, then become a maltose. Then we talk a little bit about maltose. The others are the same. So maltose is also a reducing sugar. Now what is maltose? Maltose coming from starch. It's a storage. Originally is a storage carbohydrates from the plants. Starch using amylase and partially hydrolyze become a maltose. Now where are you the maltose? This is called malting of some grain. And you know this because the beer, they have a barley. Now, why they have to do a malting, which is like immersed into the different temperature of the hot, warm water, then let them do the germination kind of thing. Because the malting will create amylase. The reason is when we prepare for a beer brewing, what's going to happen? We're using Saccharomyces, which is beer yeast. The beer yeast do not have amylase. So we have to generate amylase. Then amylase can hydrolyze the starch. Okay? That's why we have to do the malting of the grain. Most of the time is barley. And we will talk about this a little bit detail when we talk about fermentation. So then they will have a maltose, and they will have the malty flavor there. Then the beer, why it looks like a very bitter sometimes? Because we put hops, bitter acids there. That's kind of hops there. That's why it's very bitter. So maltose actually is during the fermentable. It's of course it's easier to be dissolved in the water. It's a malty flavor for a beer. So maltose doesn't really using. It's the least sweetness. So not used for sugar at all. Then people usually are very smart. They think about maltose is not really good for sweetness. Then what they do, they create the sugar alcohol called maltitol. Okay, the maltitol is widely used, so-called sugar-free or sugarless chocolate. Okay, so that's we have talked about the maltose. Okay. Cereals. This is the one we will talk very easy. Cereals is a very similar structure to maltose. And the glucose, very, very similar. What is the difference? The difference is only here. It's only right here. That is the difference. Only goes here. Okay? Now, it is a little bit different from sucrose and maltose, but a little bit similar to the maltose. The cereals is usually their hydrolysis cellulose. So this one is non-digestible. It is only using for support function, therefore used doing the fiber manufacturing, and basically is the cotton. Okay, so that's why cellulose is basically is digestible. Okay, so these we talk about these oligosaccharides. More oligosaccharides. These are in the textbook. We're not going to go down all of these one by one. Be briefly to say, isomaltose. That's another one right here. Now, if you are interested, you can go ahead to figure out why it's called alpha D glucopyranose 1,6 glycosidic beta D glucopyranose. You can go ahead to figure out that. It's easier to the conformation, which is alpha and beta. We're not going to go to the bottom of these. Isomaltose is breakdown product during production from glucose, starch, and dextrose. It's a secondary oligosaccharides. Then the second one is gentle bios. This is the glycosidic in amygdalin from stone fruits, which is peach-like. Trehalose is found in the yeast. Now, I know trehalose because when we using the biochemistry test for Listeria monocytogenes can using trehalose, so it's trehalose test positive. Okay, but I never know about that. Besides for that, I don't know the detail of those. Okay, so just to let you know, there are some other oligosaccharides, but they are in the food processing, not as important as when we talk about sucrose, lactose, and the meltos, and the cellulose. Not really that important. Here we also want to briefly mention. We mentioned sugar alcohol like sorbitol, xylitol. For disaccharides, they also have a sugar alcohol. So it's an important food ingredients in the recent years. For example, maltose going through hydrogenation will have a maltitol, which is from starch, of course. It's low negative heat of solution. Now, what's the difference between sorbitol and xylitol? When you put in the mouth, there is no cooling impact, no cooling tasting, and very high viscosity in the solution. And when we see the lactitol, it's a hydrogenation of lactose. Lower sweetness, not very sweet, lower energy value.